Okay, so we've done the button, but I want to try something a little bit different. So I'm gonna unplug the button, and you see that you can basically just do this without doing anything else. Like, you don't need to unplug the Raspberry Pico in order to unplug the button. If you're ever in difficulty with the buttons, I can get you some other breadboards if you need a lot of them. Anyway, what I want to do now is I want to write less than a 1 towards my LED. What I'm doing now is I basically blast the LED full power. I say, all right, I want you to be 1 and 1 only. That's the highest you can go, but there is an option to go in between. Basically make sure that it's not just 1 or 0, but it's a fading LED. So that means that the LED is not all the way on. What does that mean? So now if I write a little blink sketch, I'm just gonna do it for a second, remove all other codes. I can say, okay, LED.toggle, and that will get it off or on depending on its current state, and I do that every second. So now it's blinking, but it's only blinking on or off. What is happening if we want to have this fading is that right now if I would draw a graph of this situation, I'm going like this, right? So I'm turning it off, I'm turning it on, right? So this is 1, this is 0. That is the only thing a Raspberry Pico can actually do. What we can control is the amount of time it stays on and the amount of time it stays off, right? So these two we can play with. For example, if I show you the code for a second and I change the sleep to 0.01 and I'm uploading it, then you see that it does something with that LED. I think it does. Get this going. Now very little. I thought we could just like have it blink so fast that it is faintly going on, but that is not working. We need a different way. Damn it, that would have been easy. What we do need is pulse width modulation. So basically this now happens over seconds, but what we want to do is that this is at a very high frequency. That is basically happening over 1,000th of a second. What we do need for that is the PWM part of that library. So I'm adding it up there. So pulse width modulation basically means we can, I'm going to draw a few graphs here, say, okay, I want it to be longer off than I want it to be on. So this LED will be very dim. This is always going to be faster than we can actually see with our eyes. It's the same as this per second. So this is our frequency. You will see this come back. So this is very much off, but we can also do it the inverse, where it's mostly off for a duty cycle, and then it's sometimes off. So that means that it's not gonna shine at full brightness, but it is going to be very much brighter than the one on top. So that's what's going on. We will add this code now. So we have already said that it is a PWM pin, and I can also say that instead of just pin, I'm gonna write a little function around it and say, okay, you're now a PWM pin. Is that right? Yeah, I've written it correctly. So now I set to Raspberry Pico, I want to use this pin 15, and I want to use it with pulse width modulation. Not every pin can do this. There are some graphs or some tables that you can figure out to see which one can, but this is basically one of them. So we're going to use that pin. What's next? I need to set a frequency. I need to say, okay, how much time do I want per cycle for this? Like, how long? Do I want it at 1,000th of a second, or do I want to use less? We always will be using the frequency 1000. Just for clarity, always use the same. Now I can say, while it is true, I want this LED to have a duty cycle. This seems like a difficult code. It's basically the same values all over again. We will use this a lot of the time. And now we have a value which we can use for this, and it's gonna be between 1 and 65,000. So based on that, we can guess what's gonna happen. First of all, I'm gonna start at 100 and see what's happening. And that LED is not on. So just to be sure that everything is working, I can put it at 65,000. And now my LED is on. Okay, that is really cool. What if we put it midway? And that LED just changed a little bit of the brightness. It's hard to see on camera. So let's go even lower. All right. And maybe back to up. And I can control the brightness of this LED by changing this value. It's between 0 and 56,000, which is an odd number, but that's basically how long duty cycles are split up. It's a float value. But if we play with this number, we can basically just say, okay, I want you to be closer or less close. What we now could do is say, okay, I'm going to just add a counter. And that counter will be 0. And every loop, I want this counter to add up 1. Equals 1, for example. I'm going to put this the same as count. And now you can see that it briefly not just flickered on, but it went on. Now I can say, okay, if the count is larger than 65,000, put the count back to 0. And now this LED is gonna turn off, get brighter, 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 and then turn back off, right? So this is what's happening now. It's just cycling through. But you can see how fast it's counting up to 56,000. It's crazy fast. Be aware that this is how fast your Raspberry Pico is running. If you don't add any sleeps anywhere, this is how fast it's going through this loop. What we might be able to do is now maybe add the frequency as well and see if that has any influences. I'm not quite sure. Just keep it at 1, at 1000. That makes more sense. So this is pulse width modulation. Right now we are basically just saying, all right, every cycle of your script, every time you're going through the while, just make this slightly longer in relation to the full width of the frequency. Just alter it slightly, make it slightly longer just by 1, and it starts like this and it ends up like this. And once it's completely full, we just say, all right, just make it empty again. So this is pulse width modulation.